Okay, focus activity number 1 for the fourth 6 weeks. There were 42 staff members in the common room at morning tea today. Their selection of biscuits is illustrated in the Venn diagram alongside. A is the set of the staff who ate a chocolate biscuit. So all these folks ate a chocolate biscuit. B is the set of staff who ate a cookie. C is the set of staff who ate a cream biscuit. Find the probability that a randomly selected staff member ate. And then we've got A through H. Now the last two, you're going to notice they have that keyword given. What kind of probability is that? Oh, that's not implication. That's conditional probability. Okay, you remember conditional probability? If we have the probability of A given B, what was the formula?
It's the intersection of A and B.
Okay, so the probability of the intersection over the probability of B. Whatever item is given, that's the probability you're going to go ahead and divide by. All right, so what I'm going to go ahead and do, before I go ahead and turn you loose, I'm going to give you a little bit of time because I'd like you to try this on your own. Probability was kind of a big issue for a lot of people, and I want to give you the opportunity to practice it. Then we'll come back and we'll check all of our answers. But while you do that, I'm also going to pass this around. I've got a packet with times that you can go ahead and sign up to talk to me about your IA, because it's going to be due on the 7th, right before spring break. So we have less than 2 months before you got to have the final project done. So this is what the first page is going to look like, and it goes Monday through Friday of this particular week. It's the week after next. So starting on Monday, January 28th. I've got 15-minute sessions. You can go ahead, sign up for the morning, after school, 4 to 4:15, 4:15 to 4:30, and with the way our classes are, I can fit 3 15-minute periods into a single class. So that's what we're going to be doing the week of the 28th. So while I'm meeting with folks, talking about their IAs, trying to help them with any questions they might have, you're going to have another week to go ahead and work on that. Okay, if you need to do a little more research, or if you need to go back and retype something, whatever the case may be. So I'm going to go ahead and pass that around. Okay, and it's the same times Monday through Friday. All right. So basically, it's just going to be, first come, first serve. If that slot is filled up, maybe look for that slot on a different day or whatever you need to do. So I'm going to go ahead. And if you don't feel you can sign it right now because you're not sure about your own calendar, that's fine. I'll be talking about it as we go through. So just be thinking about, what would be the best time for you on what day. This is the week of the 28th through February 1st, that Friday. Okay. All right, and I'm thinking on this 3 minutes. Right? Hey.
I have a question. So on the exactly one type of biscuit or exactly 2 types of biscuit, it says like their biscuit choices are on the Venn diagram. So does that mean it's including a cookie as a biscuit?
That's a good thing. Okay. I would probably say no, because they do make a distinction between a biscuit and a cookie, so I would think no. Okay. All right, I'm going to give you 3 minutes to go ahead and take a look at that. Okay. You can also double check your answers with your villain buddies, the new folks who are around you, or if you're not sure, maybe get an idea from them. Okay. And then we'll go through, I'll write out the answers, and then we'll see how we did. Okay, and I'm going to go ahead and put the remainder of these over here in Monday's folder. There we go. Okay. So biscuit and a cookie. I'll go ahead and turn the light off. It's great. I got minute 35. Doo-doo-doo-doo-doo. 45 seconds. Now, when time is up, would you rather I go around and pick random people to just tell me what they got as an answer, or should I just list them? Just list them? Go around asking people? Let's do a vote. How many people want me to ask specific folks? 3. How many people want me to just list them? All right. I'll list them.
Mr. West, I really feel like you should just take whatever you want. I mean, who says we have to go?
It's true. That's true.
And which one is better for math?
But we do live in a democracy, at least for right now.
Well, there's passion, we don't have to.
All right. Okay, so that was 3 minutes. Okay. I'll tell you what. How about if somebody wants to volunteer what they believe the answer is, I'll go with them. Otherwise, I'll just go ahead and put down what the answer is. Okay, so Libby, you believe you have A? What's the probability that they had a chocolate biscuit? 10/21. Perfect. That is 10 out of 21. How many people got that right? Nice. Okay. Now, if somebody did not get it right, how can I help? Like, how are we finding just probability? It's what? Yeah, it's the favorable outcome, what we're looking for, over what? Out of everything that's possible. So in this case here, we're talking about a chocolate biscuit. So which one of these here was a chocolate biscuit?
A.
Remember, that was A, right? So within this circle, how many do we have here? Okay, we got 20. So 20 people who ate a chocolate biscuit out of the 42 total. Okay, well, that is going to be 10/21. Is everybody okay? All right. Anybody think they have B, a chocolate biscuit and a cookie? Okay, Eli, what do you think?
I got 540 seconds.
That is correct. 540 seconds. That's the way the cookie crumbles. All right, there we go. All right. I bet you missed them, didn't you?
Oh, yeah.
There you
I
go.
got a couple of them in the videos.
There you go. Okay, C, a chocolate biscuit or a cookie. Okay, so Haley says 5/7, so she is correct. That is absolutely right. D, exactly one type of biscuit.
What do you mean by that?
It is 29:40 seconds. There we go. Okay, so Michelle, you want to talk about that one? Okay, so exactly one type of biscuit. So we know the 42 is the total of everything in the universe, but Eli, where did that 29 come from?
So if it's exactly what you're just looking for, whatever outcome makes you one type of biscuit, so we're just looking at everything but the intersection.
There you go. So basically exactly one type would be this area here, and this area here. So the 12 plus 8 plus the 9, there's my 29.
I thought you said you weren't counting cookie as a biscuit.
See, I think, and this is where I got a little confused. There was only one problem on here that I didn't get correct, and I'll tell you which one it is in just a second. But overseas, don't they call a biscuit a cookie?
Yes.
I'm wondering if it was just the name. Okay, because I don't know.
I think they're
Yeah, so they're just trying to be real. Yeah, right. Exactly right.
and they're headquartered in Britain. So.
What's headquartered in Britain?
I thought IB was like headquartered in Britain. Or like a
Oh.
lot of politics, I'm not sure. I think they are.
Okay, sounds good. All right. E, exactly two types of biscuit. Okay, so E, exactly two types of biscuit.
So in that one, are you going to do the intersection between A and B and then the one between B and C?
Yeah, but it says exactly two, so we can't take the entire intersection. Like between A and B, we can only take that one, and then the others as well.
Would that be 3
Okay, I did get 3/14, yes. Okay. There we go. Does that make sense? Because we don't want to include the one in the middle because that would be all three. We said exactly 2. Okay. All right, now F is the one that I had a question on because here's how I read it. It says a cream biscuit but not a cookie. So the way it was worded, anybody follow what I did? What was my first thought?
9 plus.
Okay. I was thinking compliment, but not a cookie. So I'm thinking everything outside of the cookie, but apparently that was not correct. The answer is 2 7ths.
Okay, that's what I got. I'm not really sure how I got that.
Okay. Because it says a cream biscuit, but not a cookie. So we definitely know where we got the 42. All right. Well, where do we get the value that with the 42 simplifies to 2 7ths?
So it's 12/42. Oh, so you're doing 9 plus the 3. So
Yeah.
everything that we
There you go.
have-
So see, it's a cream biscuit, but not a cookie. Okay. Did anybody else have the idea that when it said but not the cookie, did anybody else think compliment, or was that just me? Apparently it was just me. There you go. Okay. So 2 7ths. That's the only one that I missed. How many people got that one right? All right, there you go. Okay. And then our conditional probability. A cookie, given that he or she ate a chocolate biscuit. Who believes they have this one? Okay, Spencer, what do you think? 1/4. That's right. Do we want to talk about this one? Okay, so let's see. I'm going to go ahead and write this out using what we have here. So I'm going to go ahead and say the probability of eating a cookie. I'm just going to go ahead and say C. Okay, given that we ate a chocolate biscuit. I'm not going to worry about the abbreviations they have. So the formula I'm looking for is the probability of eating a cookie and a chocolate biscuit divided by the probability of what? Always the probability of the given event, the chocolate biscuit. Okay, so what's the probability of eating a cookie and a chocolate biscuit? Okay, 5/42. Out of the probability of eating a chocolate biscuit? Okay, that is 20. 40 seconds. And what happens when you divide by a fraction? Okay, so you have 5/42 times 42 20ths. Those are going to cancel. The 5/20ths, there's our 1/4. Okay. How many people have gotten that one right? Okay, good. Good, good. And H, a cream biscuit, given that he or she ate a cookie. Okay, Samir, what do you think? 1/5. 1 out of 5, yes. Perfect, perfect, perfect. Do we want to talk about this one?
Yes.
Yes? Okay. So we're looking for the probability of eating a cream biscuit given the probability we ate a cookie. Okay, so if I apply that to the formula, the probability of eating a cream biscuit and eating a cookie, and then we're going to divide that by the probability of eating a cookie. All right, so what's the probability of the intersection? Okay, 3 out of 42. 3 out of 42, and then we're going to divide that by the probability of eating a cookie. 15 out of 42. Okay. And is everybody okay where we got those ratios? Does anybody want me to talk about where we got them in the diagram? Okay, so dividing by a fraction means to multiply by the reciprocal. 42s once again cancel. 3/15. There's my 1/5. Okay, questions? Hey, Gabby. Okay, so I'm thinking the way it's said, like I said, I got messed up on this one too. It says a cream biscuit, but not a cookie. So anything that falls into the circle that's the cream biscuit, but doesn't intersect with the cookie circle. So there are 9, 10, 11, 12 out of the 42. And that's where we were able to get the 2 7ths. Okay, good. Questions? All right. Well, the next focus activity is going to be probability as well. Go ahead and put this someplace safe. Probably in a week or so, I will have you turn those in for a quiz grade. Good. Good. That is that's definitely something we will revisit again. Probability. All right. So let's see. Is that packet still making its way around? Who has that right now? Okay. Is there anybody who has not had a chance to look at it? Okay. So let that keep going. All right. So let's see here. Here we go. That was last year's. Okay. And what we started talking about last week was systems. We have not yet gotten into quadratics. With the time the way it is, we might get to that tomorrow. We kind of saw a preview of it. But let's see. I think, did we just talk about the matrix equation, or did we actually solve one? Okay, and let's go ahead and do C. I believe that was the one we were going to look at. You didn't get it from the website? Oh, might still have some copies over here. Let's see. What day did I give that to you? Was it Friday? Yeah, here we go. There you go. There you go. Okay. I couldn't remember if we started this on Thursday or Friday. There we go. Friday. Okay, so I wanted to go ahead and do C. Okay. So let's see here. To kind of catch up, we talked about creating a matrix equation after we talked about elimination and substitution, just good old algebra. The coefficient matrix is made of your coefficients. Okay. Very important if it's being subtracted, you want to make sure that element is negative in the matrix. We have our variable matrix made up of the unknowns we're trying to find, and then my constant matrix. Okay, so we have A, X, and B. Now, if we go ahead and type these in the calculator using this notation, A inverse B, it's going to automatically go ahead and calculate what the unknowns are. So let's get right into it. We're looking at C. So I want to go ahead and write matrix A. So it's a 2 by 2. What would be my top row? 5, 7. Okay, and then the bottom row would be 3, 8. See, I'm taking those numbers just right off the equation. Okay. Now with this, you definitely want to have them in standard form, that AX plus BY equals C notation. So say on B, if you wanted to solve this, you want to go ahead and subtract the X over, okay, so that you have that correct form. Now we're going to have matrix X, which is always going to house the variables, equals matrix B, which we call the constant matrix. In this case, which is just 11 and 18. Okay. So is everybody okay with how we come up with what's known as the matrix equation? Okay. Well, all I have to do is go ahead and just type this in, A inverse B, and it should go ahead and give me exactly what it is I'm looking for. Now, here's the thing. You can go ahead and type it in using a letter. You can go ahead and store it, but I don't think that's really necessary. I would just say, let's just go ahead and type it in. So if you go over here to between 9 and your catalog, this open book right here, remember this middle row is great for matrices. So I want to type in this. I believe it was 5, 7. Was it 3 and 8? Okay. 3 and 8. Now I'm going to cursor outside, and I'm going to go ahead and raise this. So I'm going to use the caret button. Looks like the top of a house. I'm going to go ahead and put -1. Then I'm going to say times, and I'm going to go ahead and put in the matrix, the constant matrix. So let's see here. Go back to the same button. Here we have a 2 by 1. And what was it, 11 and 18? There you go. So the inverse of matrix A, I'm showing the calculator I want the inverse by raising it to a power of -1 times matrix B. As soon as I push enter, boom. So X should be -2 and Y should be -3. Or +3. Ooh, it's a Monday. -2 and 3. Okay. There we go. So if I go ahead and plug those in, I should be able to get true statements. Like, for example, 5x, 5 times -2, plus 7y, 7 times 3, should end up giving me 11. Well, let's see, 5 times -2, -10 plus 7 times 3, 21 should give me 11, and yes, it absolutely does. All right. Okay, questions? Okay. Thank you very much. Okay. All right. Now remember, the strategy isn't that important. These matrices right here, if I were to go back and look at some of the other matrices that we solved, if I solved it using matrices, you're going to get the same answer. Elimination, same answer. It's very rare that it won't give you the same answer because the strategy might have some kind of restriction. Like if you're going to use Kramer's rule cannot be used on every system. Okay. But maybe at some point I'll go ahead and show you that strategy. But I think, with these three here, really you've got four because you remember how I showed you to type it in the calculator the other day? Or do we need to revisit that?
Can we go over it?
You want to go over that again? Okay. So let's take C and let's go ahead and plug it in. 5x plus 7y is equal to 11. So from my scratch pad, where did I go? Menu. Algebra. Solve systems. And here you go. You can change the size of the system if you want, but we have two equations, two unknowns, and we just go ahead and type it in. What was it? 5x plus 7y, and the equals is right over here below your blue control button, 11. And then what was the other one? 3? 3x plus 8y equals 18. Okay, you just type it in. Now for the calculator, what you're doing here, does not have to be in standard form. I mean, it could be in slope-intercept or any other form, really, for that matter, as long as you have the equation. And then just go ahead and push enter and see it gives me the same result. Okay. All right, good, good, good. Okay, and I think I was going to go ahead and do 4. Okay. So the sum of two numbers is 2, while their difference is 6. Use a system of equations to find the numbers. Okay, so let's see. First off, we need variables to represent the unknowns we're finding. Okay, Carolina, what variables would you like? A and B? Okay. So it says the sum of two numbers is 2. So if we're using A and B, what's my equation? A plus B is equal to 2. And then it says, while their difference is 6. So difference, the key word A minus B, is going to give me 6. Okay. And out of all the strategies that we've looked at so far, which one is just going to immediately give me my answer? Elimination, yeah. We're just going to add them up because these are already set as opposites. So remember, that's when you add your equation. So A plus A is 2A. Opposites cancel is equal to 8. So we know A is equal to 4. Okay, but remember, that's only part of it. You still got to find the other variable. But that's easy enough. 4 plus what is 2? Negative 2. Okay. There you go. Questions? All right, so we're going to put the systems aside for just a second. What I want to go ahead and do is look at factoring. Okay, and you've got an example already provided for you here. The ones I want to go ahead and take a look at are A, D, E, and G. A, D, E, and G. Okay. Now, did anybody have the opportunity to go look at the factoring map that I provided them? Okay. If you do, it's a really great resource if you ever forget how to factor any kind of polynomial that's given to you. Very, very first step, always look for a what? Always look for a common factor. So x squared minus 6x plus 5. Is there anything all three share? No, besides 1, so there's no GCF. So whether there is or is not, that's when you go ahead and try to break it up into some group factors. In fact, does anybody know what we call it if it can't be factored? Starts with a P. Prime, there we go. We say it is a prime expression. All right. Now, here's the thing. If it's a simple trinomial like this, you probably don't need that method that I was referring to at the beginning of class. Just think about this. What two numbers would multiply to give me a positive 5, but those same two numbers would have to add to give me a negative 6? Negative 5 and negative 1. So x minus 5 x minus 1. Sometimes it is just that easy. Negative 5 times negative 1 is positive 5. Negative 5 plus negative 1, there's your negative 6. Okay. Now, if you take a look at D, 6x squared minus 5x minus 4. Okay. So here's the thing. Is there a GCF? Nope, they all three don't have the x. 6, 5, and 4. The only common factor is 1, so we're going to forget about the GCF. Now, this is why, I mean, if you still want to use the guess and check method, or if you have a method that works, I really encourage you to use it. But if you're going with guess and check, you have to think about, you know, the different combinations that you could have. Like in order to get the 6x squared, you could have x and 6x, then you could have, you know, 2x and 3x, and then you got to figure out, could that be 1 and 4? Is that 2 and 2? And it's still going to work, right? Eventually you're going to be able to get to your answer, but that's why I like this one method. My father drives a red Mercedes convertible. What did the M stand for? Multiply. I'm always going to multiply the first coefficient by the constant. So 6 times negative 4, negative 24. Okay. Now, because it's negative, this one's a little nicer to us. The only way to multiply and get a negative is one has to be negative, one positive. So this is the crucial step. This is my factor step. What two numbers will multiply to give me negative 24, but those same two numbers will add to give me negative 5? 8 and 3. Which one's which? Negative 8 and positive 3. Now, the reason I ask, negative 3 times 8 is negative 24. So why can't we do it that way? There you go. Your sign is really important. Negative 8 plus 3 gives you negative 5. Negative 3 plus 8, that would give you positive 5. So you always want to pay attention to your signs. Okay. So once you get that, you get those two values, the rest is simple. Easy. Okay. What did that D stand for? Divide. Okay. So we always divide by that leading coefficient. This time it's a 6. Okay. So my father drives. We multiplied, we factored, we divided. What did the R stand for? Reduce. What is 8 6? Okay. And what about 3 6? 1/2. And then what did the second M be? I wanted to move those numbers. So I got a text message. So I'm going to go ahead and get my two binomials ready. Now remember, we always start from the denominator and we work our way up. The denominator, that's the coefficient. So here we have x, so negative 4/3 would be 3x minus 4. What would 1/2 be? Would it be plus or minus 1? Plus, because the 1 is positive. It's a positive fraction. So that should be the factorized version of D. Basically, when you're asked to factor anything, you're asked to reverse the multiplication. What monomials, what binomials, what trinomials am I going to multiply to give me the expression that I have? Okay. Like I said, if you like another method, please, feel free to go ahead and do it. Absolutely. I'm not pushing this. This is just the way I like to factor. Okay. All right. So if you like it, great. How many people like this method? Okay. All right. All right. As long as you're able to factor, that is all we're after. All right. So I'll tell you what. I've got 207. Let's go ahead and stop there for today. And we'll pick right back up with E when we come in tomorrow. Okay.